Hello everyone and welcome to today's webinar, IT Transformation and the Private Cloud. My name is Laura Ventura and I'll be your moderator today. Joining us are Chris Kemp and Mike Soby. Chris Kemp is the co-founder and chief strategy officer at Nebula. And prior to Nebula, Chris was the chief technology officer for IT and NASA, where he co-founded OpenStack and was responsible for pioneering work in cloud computing, open source, and open government. Mike Soby is the president and CEO of CumuLogic, and before joining CumuLogic, Mike was VP of Cloud Services at CA, having joined CA after they acquired his previous company, Forbase Technology, where he was co-founder and CEO. Throughout our presentation, we encourage you to submit questions using the questions pane on GoToWebinar, and we will answer questions live at the end of the presentation. Please keep in mind that all participants are in listen-only mode, and we are recording today's session. And we also will email you the link to the recording tomorrow and post the links on CumuLogic and Nebula websites. So let's get started, and we'll kick off today's webinar with Chris Kemp.
Thanks. Looking forward to sharing with you what we've been working on with CumuLogic and a little bit of background on what Nebula is doing with OpenStack. So can I kick it off? We started working on this technology over 5 years ago at NASA, and in fact the original project, the NASA Nebula project, was really the genesis of the Nova compute engine in OpenStack. And as we built that technology, we open sourced it, and we had a lot of companies come forward, starting with Rackspace, and make a lot of contributions. And over the past couple of years, we've seen a tremendous growth in OpenStack with many service providers and enterprises now beginning to deploy it in very large production clouds. And what's exciting to us is the kind of trends that are behind this. We're seeing an increasing number of enterprises building infrastructure to support an ever-increasing amount of data and computation that's required to accomplish their mission. A couple of examples. We pulled a few of these from one of our investors, Kleiner Perkins, Mary Meeker, an analyst, puts about 150 slides together every year giving us all a status on the computer industry. And we see this year over 500 million photos being uploaded every day to the top 4 popular photo sharing sites and Facebook. And this is a profound implication to enterprise computing, because as we start to see the technologies that Facebook is using to store 300 million photos every day percolate into the products that you're able to buy from popular vendors like HP, Dell, and IBM, we start to see a whole new kind of economics emerge in enterprise computing. And it's not just limited to photos. It's also impacting the consumer market for computers. If you start to look at the market share over time between desktop, notebook, and tablet PCs, it's really started to shift towards more portable mobile devices. And the implication here, of course, is that the components like flash chips and ARM processors that are used in mobile devices will become more pervasive in enterprise computing. And as a result, large x86 servers and hard disks, which have been really the mainstay in enterprise computing and storage over the past 10 or 15 years, will be a lot less relevant, because, frankly, the flash chips and the low-power CPU architectures powering our mobile devices will become much cheaper to integrate into enterprise computing environments, and we're already starting to see that with companies like Fusion.io and others. So what we're really seeing now is a large chasm between companies that invest a lot of money in their application stacks and companies that invest a lot of money in their infrastructure. And if you look at on the bottom part of this slide, the ever-growing investment that companies make in their infrastructure, there's more or less no more expensive way to flip, move, or store bits of information than how the typical enterprise does it today in their data center, which is to run a VMware stack, a lot of expensive blade servers from vendors like Cisco, and big network switches and big storage appliances. And one of the challenges is if you have a really big problem like storing 300 million photos every day, like Facebook does, it just doesn't work. And so we have on the other end of that spectrum folks that spend very, very little on the components of their infrastructure and invest little in the individual servers, often as few as a few $100s. We see companies that have multi-billion-dollar application stacks at the high end of that spectrum, and that's not a practical place for most enterprises to be either. So there's a sweet spot in the middle, and I think what you're going to learn about today with Nebula and CumuLogic is that sweet spot and how we achieve building applications on infrastructure that's not quite as cheap as what Facebook and Google do, but it's a lot less expensive than what you'll see in the traditional data center environment in enterprise. And every application is a point on this graph, and most enterprises have thousands of applications, and if you're listening to this webinar, you're probably thinking of a few right now where you'd like to run it on more Google-like or Facebook-like infrastructure. And they're typically applications that scale out well, that are able to be distributed across a large number of very inexpensive servers. Good news is a lot of these applications are being open sourced by the internet companies. You've all heard of Hadoop and are probably consuming it from companies like Cloudera, MapR, Hortonworks, etc., or using Scaleout database technologies or storage technologies from some of these organizations. So what Nebula is doing, and you're going to see a demo here in a few seconds, is we built a cloud computer that really tries to take a lot of the approaches that Google and Facebook and other large internet companies use in their data centers, and it makes it a system that you can easily and very inexpensively buy and deploy in your data center. So think of it as a little public cloud running right there on premise in your data center. The idea there is that it's something that's easy to buy. You don't have to build it, and you also don't have to rent it. So there's a new opportunity to have cloud that's right there in your data center. Challenge with the cloud is that most of the applications that you've built in the past were built on static infrastructure that were privately owned by application owners, purchased at fixed cost, relatively inaccessible, and with this cloud world we have on-demand, elastic, shared, metered, and accessible infrastructure. So there is this transition that you need to make as you put developers and the applications themselves in the driver's seat. And the challenge is a lot of enterprises don't know how to do that, and what I'm excited to share with you shortly here is how CumuLogic makes that easy and makes it a lot more accessible to the enterprise. So before handing it over to Mike, one of the things that we like to talk about is all of these computing environments have a role in the modern enterprise. And if you have applications that are able to manage their own reliability and scalability, think of the Netflix stack or really any application that can run in Amazon, you can run that nicely in a cloud because the application is making itself more reliable by running more instances or running in different geographic availability zones. If the application needs to be faster, it simply scales up more resources and distributes the load with load balancers across more compute. But if your application really does require that infrastructure layer to ensure that it's a reliable or really fast infrastructure to make sure that it runs quickly like a traditional relational database, you do want to run that on a traditional either bare metal or VMware environment in your data center because it's the best, most reliable place to run an application. Security and data gravity play a role as well when you're thinking about moving up and down this chart between the public cloud and the private cloud services. If you're generating a lot of the data that you use, you should probably, and it's on your network and it's local. A lot of these are examples. We have render farms and movie studios, gene sequencers and biotech firms, geospatial sources of data from satellite infrastructure. This is a great place to run a public cloud. So this is a good framework to think about as you manage what applications run in the public cloud, private cloud, in VMware, and other places in your data center. So with that, I'm going to hand it over to Mike and show you a little bit about how we'll talk about CumuLogic and how it complements Nebula's infrastructure services. Mike, off to you.
Great, thanks, Chris. I appreciate it. So Chris had some very compelling points about the shift in how infrastructure is being consumed, how it's being constructed. One of the things with CumuLogic and why it's such a great partnership for us with Nebula is that the complementary fit is 100%. What we believe in CumuLogic is that to complete this notion of this, as Chris put it, right, little public cloud inside the firewall, not only do you need the compute and the disk, but in order to kind of move along that continuum closer to where the developer really can be empowered, you also have to have upstack services. So we're a firm believer in the fact that the complete story is infrastructure as a service plus upstack services. And those upstack services could be any combination of platform as a service, database as a service, be it SQL or NoSQL, caching, load balancing, message queue, DevOps as a service. This entire suite of sort of developer-empowered services needs to be in place to create that entire little public cloud inside your firewall, and that's where we pick up, and that's why it's such a great partnership for us with Nebula. If you think about what that means, it really means that you've got this abstraction layer that abstracts the actual applications from the infrastructure. So for us, what we want to do is completely abstract that infrastructure experience from the developer, from the end customer, so that the net result is that the developer gets what they need when they need it, and they get it in a matter of a couple of mouse clicks. So it's not a matter of configuring VMs anymore. It's not a matter of configuring bare metal servers anymore. It's not a matter of loading databases. It's really requesting a service. And the service is managed, it's monitored, it's backed up, it meets enterprise governance requirements. It can be charged back, it can be billed back, and most importantly, it's a true multi-tenant, multi-cloud infrastructure. So deployment, to Chris's earlier slide about the 4 quadrants sort of public, private, managed, etc. We believe that should be completely abstracted from any user. Any credentials that they have should allow them to deploy services, whatever service they require, be it database, a complete platform stack, or DevOps, or whatever it is that they require, needs to be able to be deployed against any stack. So theoretically, a user should be able to log in, have access to their internal Nebula cloud, have access to some sort of external sanctioned cloud, and be able to determine where that workload or where that service or where that entire application needs to be deployed. And that's what we believe. If you're familiar with the market, and I'm sure everybody is, and you wouldn't be on this webinar if you weren't, Amazon is truly the kind of 800-pound gorilla in the space, right? None of us are blind to that. We actually believe that we should embrace that. We believe that Amazon has set a great model in terms of usability. We believe that Amazon has created a model that is very flexible, very modular, and works. The challenge you have with Amazon is that you have no control over it. It's outside your firewall. It is outside the sanction of the enterprise. It's outside of the governance requirements. It's outside of any Sarbanes-Oxley requirements or others that your individual enterprise may have. So our mission with Nebula is to mimic what Amazon's been able to do in the public realm and bring that into the private realm. So in this notion of empowering developers, playing to the notion of the public cloud inside your firewall and mimicking that. This is really what CumuLogic is set up to do, is create a suite, a single pane of glass that really represents a lot of the functionality that you would get in Amazon, and that's reflected here in this slide, and receive that inside your firewall on top of your Nebula environment or on top of your hybrid environment, be it a Nebula external environment. So the user logs in, and a user, for instance, who may be accustomed to using relational database, RDS, on Amazon, is going to have a nearly identical experience with the CumuLogic RDS module sitting inside their firewall on top of their Nebula environment. And that's our goal, is really to take these upstack services, complete the picture for a true public cloud inside your firewall. And that's what CumuLogic does, and that's why working with Nebula and partnering with Chris and his team is so important to us, because we don't do the infrastructure piece, we don't do the compute, the disk, the networking. That's their expertise, and then we take the handoff from the upstack to be able to complete the entire picture. So use cases. I'm just going to spend a quick minute here on use cases because I think that's important to everybody to understand where this fits, where we're actually seeing customers use this solution. One area that is incredibly pervasive today is actually what we're kind of generically calling Amazon outgrowth and repatriation. I kind of hate to use the Web 2.0 moniker, but it seems to apply. You could also substitute it in SaaS, any SaaS companies. These are typically companies and typically organizations that grew up in Amazon. They started from day one using public cloud services, again, sort of ubiquitously calling out Amazon here. But what they found is they've reached sort of an inflection point. They reached a point where they need to make a determination about what their go-forward strategy is, and their business has grown to such a point that there are two common problems that arise. One is that costs tend to get out of control very quickly, and the second is that there's no diversification and there's no control. So these in this use case, in this AWS outgrowth use case, what we're finding is their customers there are trying to figure out, how do I gain more control over my infrastructure? How do I bring some of it in-house? How do I diversify my risk a little bit? And how do I control those costs? Because once you get to a six-figure monthly bill from Amazon or any other provider, it tends to be a bit onerous, and that seems to be the inflection point at which most people are starting to look at bringing resources in-house. Enterprise IT build-out. So this is really playing to the notion of IT as a service. These are customers that we work with that are interested in empowering their developers, empowering their end customers, and trying to take IT ops out of the equation as much as possible. These are organizations that really believe in this notion of IT as a service. They want to build self-service. They want to empower users to not only provision VMs themselves, but actually deploy application stacks themselves and actually deploy databases and receive the services they need on a completely self-service basis. And this is spread across the spectrum of vertical industries. These are organizations that really believe in the notion that resources can be deployed in a much more efficient way if you can empower your end customers. Playing to that is also this notion of shadow IT offset. We're working with a lot of customers today that are actually having to cut off Amazon repayments. Users that are using their credit cards to swipe to instantiate Amazon services are now being directed back inside the firewall to use their OpenStack cloud with CumuLogic services on top of it. And it's an important aspect of creating the similar experience to someone who may have a problem with shadow IT. Shadow IT, by definition, really in our world, is individual users swiping credit cards and going outside the firewall to instantiate services to get their applications written or to get their jobs done. And what large customers want to do is cut that off, bring those users back inside, but give them a like experience, give them a similar experience, and that's a common use case for us. And then true hybrid cloud services, right? Again, this speaks to Chris's slide a few slides ago where he had the 4 quadrants, where you may have some managed services, you may have some public cloud services, you may have some private cloud services, you may have some private infrastructure services that may not be completely cloud automated yet, and all of those need to be seamlessly available to the end customers, and that's what we believe in. So we believe that we are that abstraction layer that allows users to deploy applications, deploy services against whatever infrastructure is provided to them. So those are some of the common use cases that we see. So with that, we have a demo prepared for you. A picture is always worth 1,000 words. So with the demo, I think we will kick that off. It's been prepared in advance to try to save some time. And we will launch into that now so you can actually see what the solution looks like in practice.
Nebula One is a turnkey infrastructure as a service platform based on OpenStack that provides elastic compute, storage, and networking services. The solution consists of Nebula hardware and software coupled with certified industry standard servers known as cloud nodes. At the heart of Nebula One is the Nebula Cloud Controller, a hardware appliance that provides the cloud infrastructure management and orchestration services. Your workload runs on the servers that you plug into the cloud controller. The disk's CPU and memory are all added to the shared pool of resources in the cloud when you plug them in. Nebula supports compute, block and object storage, and network out of the box with no other third-party hardware or software, with the exception of the servers you plug in. Let's go ahead and take a quick look at how easy it is to provision resources with Nebula One. The Nebula console is an intuitive, easy-to-use self-service interface. To quickly start consuming resources, let's go ahead and log in, and then click on the Compute Cloud app. So from here, we can select from a variety of images to launch an instance from. For the purposes of this demo, we're going to click on the Ubuntu 12.04 image. We're going to name the instance Nebula Instance 1, and we're going to choose a flavor. Flavors are virtual hardware templates defining sizes for RAM, disk, number of cores, and so on. And for this demo, we're going to choose the n1.tiny flavor, and we'll click Launch. After a few moments, we have a computing resource ready for use. So by default, all cloud instances are behind a built-in firewall called security groups. If you would like to expose the instances to your network using NAT, we can add a floating IP address. In order to do that, we just click on Add over here and hit Add. So now an IP address is being pulled from the resource pool and attached to our instance. It's also possible to define custom firewall rules via security groups for any instance. So for instances requiring additional storage, we can add storage volumes that appear as block devices to the instances by clicking on Attach over here. And then we'll click on the plus sign to create a net new volume, and we'll give it a name, we'll give it a size, and we'll click Create. So once the volume has been created, we're going to click Attach, and now that block volume has been attached to the instance. Nebula also supports an object storage that is S3 API compatible. For those who prefer to programmatically interact with the cloud, Nebula supports the OpenStack infrastructure-as-a-service APIs, along with Amazon's popular EC2 and S3 APIs. In order to find out what the API endpoints are, we're going to click up here and choose API Access. CumuLogic augments these infrastructure-as-a-service APIs with a full range of platform services. Now let's go take a look at how we can use CumuLogic's platform as a service to rapidly deploy databases and applications with Nebula One.
The CumuLogic platform is an Amazon-compatible suite for developing and deploying mobile and web applications on any cloud. CumuLogic PaaS eliminates the need for developers to install, configure, and manage the application infrastructure, empowering them to do what they do best, coding quality applications. The platform integrates with Nebula One and extends the capabilities of OpenStack compute, storage, and network with application infrastructure service to build a highly scalable private cloud. Nebula One integrated with CumuLogic platform is a comprehensive cloud solution and provides not only infrastructure as a service, but also platform as a service, database as a service, NoSQL as a service, such as MongoDB-as-a-Service, and more. Now let's log into the CumuLogic dashboard. Let's walk through some of the cloud services that we have integrated to run with Nebula One. One of the most important Amazon Web Services is RDS, Relational Database Service. Let's take a look at how the CumuLogic Database Service provides RDS-compatible cloud services for hybrid clouds. Our goal is to keep parity with Amazon Web Services. So if you're familiar with Amazon RDS, the CumuLogic Database Service shouldn't look any different in terms of concepts, features, and operations. Similar to RDS, to launch a database instance, we'll click on the Details tab under Database Services and go to the predefined subscriptions or plans. Here you can see we have two different sized database instances we can choose from. A small MySQL database instance as an example, and if you don't wish to customize operational related features such as automated backup, frequency, or retention policies, then simply select Launch to provision the database. Enter a database name and click Launch. CumuLogic's platform installs monitoring agents to check the availability and performance of the database. All database instances are by default configured for auto backups daily, which can be customized by the user. Looking at the Nebula One interface, you can see the MySQL instance being provisioned now. Now, while this database instance is getting provisioned, let's take a look at other features such as creating replicas for scaling out applications. We'll use an existing MySQL instance to show adding a read-only replica. Simply choose Read-Only Replica from the Actions menu to do so. This will launch a new slave instance and configure replication from the production DB database instance. You can now configure your apps to perform reads from the slave and continue to do write operations on the master database. Just like Amazon RDS, CumuLogic Database as a Service allows you to restore or provision a new database instance from your existing snapshot or as an on-demand snapshot. Here we'll click Create Snapshot We'll select an instance, and then we'll give it a name. And then click Create. It's also possible to do a point-in-time restore for times when you want to restore from a backup. CumuLogic performs backups of transaction log files and can restore your database to a particular time from the last snapshot. CumuLogic Database Service is very similar to Amazon Web Service, RDS, and you will notice similar functionality called parameter groups, access groups, to customize the performance metrics and security groups on the database instances. That was a feature of one of CumuLogic's cloud service. Now let's switch gears and see how we can deploy applications on CumuLogic PaaS. CumuLogic PaaS supports Java EE, Spring, Rails, PHP, and Python, with support for a variety of frameworks and data services. To deploy an application, select Deploy App and provide the application name and application artifacts, which in the case of Java apps are WAR files. Then we'll select an optional descriptor file and the test web WAR file. Then we'll click Deploy. Once we've uploaded the application, the CumuLogic PaaS introspects the application's descriptor file to identify the services required to deploy the app. Here we see the app is Java EE, which uses a Tomcat engine and an Nginx load balancer. Then we'll click Finish. And in a few minutes, this app will be accessible. You can view the configuration events under the Events tab. The CumuLogic Autoscaler will scale application tiers based on default CPU and memory thresholds. CumuLogic Health Agents are constantly monitoring the health of provisioned services and will recover these services in the event of a service or instance failure. If you'd like to customize autoscaling thresholds, you can choose Autoscaling from the Actions menu, and then click on the parameter name and whatever you would like to set that threshold to. As you saw, you can rapidly deploy clustered databases and multi-tiered applications using CumuLogic's solution with the Nebula One private cloud.
Thank you for the great demo. And at this time, we would like to take question and answers from the audience. And we actually have one already from the audience. And this is addressed to CumuLogic, but also, Chris, chime in, please. But basically, they're asking if CumuLogic offers migration services from AWS.
Yeah, thanks, Laura. So the answer is absolutely. We can help anybody migrate applications or workloads from Amazon into the private cloud. Moreover, we're big proponents of not only feature compatibility but API level compatibility. So in the demo you saw the deployment of database, for instance, and a lot of RDS similar features. We actually are not only feature compatible but API compatible to RDS. So if an RDS user, for instance, wanted to start using the CumuLogic RDS equivalent on their private cloud, they would have absolutely no loss of any workflow scripts, anything else. It's a full fidelity API. So it's not only can we help migrate off of Amazon, but it's a near seamless migration. And I know, Chris, you guys have a very similar API level compatibility with Amazon as well.
Right. Yeah. In terms of EC2, S3, EBS, the networking features you're used to in Amazon, you'll see that'll be a very smooth transition onto Nebula's infrastructure services. And of course, you'll have the same model where you don't have to worry about operating the cloud. You just add a handful of servers and plug them into the cloud controller, and it is as hands-off as the Amazon infrastructure is. The ROI can be as quick as 3 months, depending on which Amazon services you're using and how elastic your workload is.
All right. Another quick question from the audience to both companies. What is your position on AWS compatibility?
Yeah, so we covered that a bit just now, sort of a very similar question, right? I think it would be redundant to go too far into that again, but I think both of us are in agreement that we are extremely AWS compatible, and I think that's to the direct benefit of any customer who's coming up with some of those challenges that we talked about earlier in the use cases.
All right. One other question for CumuLogic. Can I use CumuLogic platform if I have a custom requirement and there's a service or module that is not supported at this time by your platform?
Yes, the answer is absolutely. We believe in a very open architecture. So what we've done is, with the platform, we don't want to limit any of our customers to our own rate of innovation. So what we're doing this later this year and coming up here in Q4 is we're actually going to release an SDK with the product, so our customers can actually work with ourselves or themselves or our integration partners, and they can actually build out their own modules or their own flavors. So if there's a particular flavor of database, or there's a particular flavor of app stack or some container or something that you as a customer are going to particularly need to support your enterprise, and we haven't gotten there yet, we are fully encouraging you to do that and build that out yourself, and we will fully support the platform, and you will have that full ability to customize.
All right, and we would like to remind people if they can submit questions through the questions pane that you can see on the GoToWebinar control panel, and feel free to submit additional questions. We have at this time one more from the audience. If you have compliance data that will never leave or go beyond the firewall, can you still scale out in the computing the computing resources in the public cloud for peak periods?
That's an interesting one. I might be able to field it. I mean, I think that what we tend to find is, first of all, it really depends on the data. It depends on what kind of compliance issues you're dealing with that particular application and your particular data. However, if you were to look at it purely from a risk perspective, and really security and compliance is really a risk management exercise. We see a lot of companies that will operate 99% of the time behind their firewall, and it is acceptable in circumstances where they have unanticipated demands on the infrastructure, or they have a failure of their infrastructure. For a very short period of time, they can operate some of that infrastructure in a secure way in a public cloud, and this is a lesser evil, if you will, than having that data not be available or that application not be available. And it's something which they've described in their security plans as a risk mitigation trade-off between security and availability. You wouldn't always want to run that in the public cloud, but we do see that conversation in some customers where they don't want to put the data in the public cloud as a general practice, but it provides a safety net in cases where their internal infrastructure or networks or what have you fails. And the reverse is true as well, where we've had outages in the public cloud infrastructure where they've been able to move workloads completely into the private cloud infrastructure for the duration of the public cloud outage. So I think it comes down to building your applications so that they can take advantage of public and private clouds. And CumuLogic makes that a lot easier and takes a lot of the burden off of your developers as they're building their applications.
I'll add to that real quick too. Thanks, Chris. Just from our perspective, one of the things, because because CumuLogic was built from the ground up to be a private solution and inside the firewall solution, we've from the very beginning taken security very seriously, taken governance very seriously. So role-based access, role-based quotas, those are all built in. So in the CumuLogic platform, the administrator has the ability to define access areas, clouds, be it public or private or different subsets therein, for particular users or groups of users. And that can be tied into Active Directory or LDAP or whatever the particular requirement is. So if it's a non-event driven exercise and it's more of an ongoing business exercise, we also have the ability to define which users have access to which particular bits of infrastructure, which kind of plays into that same realm.
Great, thank you. So one other question from the audience. What kind of support staff should I expect to have on staff to administer the infrastructure as a service portion of the Nebula CumuLogic joint solution? Because OpenStack seems to be a bit complicated.
You don't really need any on-site support, which is really the value of our product. It is a true appliance. It installs in about an hour, and we walk away the day it shows up with you and your developers fully trained on how to use and support the system, and it should operate reliably with no one monitoring it or managing it or operating it. If you have an issue, there's a little button you press and you can get Nebula support on the line. I think with CumuLogic, this really allows you to invest all of your energy in DevOps and using platforms like CumuLogic to build your applications. And building your applications to take advantage of infrastructure and platform services should be 100% of your focus with a Nebula CumuLogic system. You should spend no money or energy building the cloud or operating the cloud. You truly have a buy option at this point.
Great. We have no further questions from the audience. So on behalf of our presenters and everyone at Nebula and CumuLogic, thank you for joining us again today. We really appreciate your time and we hope you have a great day.